All right, guys, last problem for today. And we got this last one. Obviously, it's very similar to the one I did on the last video. So again, you can go back and, you could use the quotient rule all you want. And by all means, if that's how you would rather do it, have at it. You can come up with the correct answers as long as obviously you don't make any mistakes along the way. I'm going to attack this guy the same way I attacked the last guy. Okay, and so I'm going to rewrite it as a product, okay, using negative exponents, okay? So this would be the derivative of the numerator squared, okay? So cosine of 2x squared, like that, times, okay, the denominator squared, okay? Or I'm sorry, the denominator to the negative second. So that'd be the sine of 3x minus 5, okay, to the negative second, like that. Okay, so I'd have to use the product rule here. Okay, so let's see what we can come up with here. Okay, so the derivative would be the first guy, cosine of 2x squared, times the derivative of the second guy, d dx, sine of 3x minus 5 to the negative second, plus the second, sine of 3x minus 5 to the negative second, times the derivative of the first. Okay, so the derivative of cosine of 2x squared. Okay. All right, so obviously, just like the last one, we just keep bringing this guy down, okay? But I have to use the chain rule there, and I have to use the chain rule there. Okay, so the first iteration of the chain rule, let everything inside that's being raised to the negative second power be your u. So the u is the sine of 3x minus 5. Okay, and then over here, same thing. Let everything on the inside be your u, okay, to the second power. So your u is cosine of 2x squared, like that. Okay, so we'll just bring that guy down. And I tell you what, remember at the end of the first one, I kind of cleaned it up by getting rid of that outside set of parentheses. I'm going to do it right now. Okay, so this is the same as the cosine squared of 2x squared, like that. Okay, so this is my u, so it's like taking the derivative of u to the negative second. So I'm going to get negative 2u to the negative third times du dx. Okay. All right, this guy right here, technically you have a negative exponent. I could start messing around with that guy, go 1 over. Okay, so I could do that now, or I could wait till later. I'm going to do it now. So I have 1 over, and then I want to get rid of that outside set of parentheses. So that would just be the sine squared of 3x minus 5. Okay, so that guy's cleared up a little bit, or cleaned up a little bit. Okay, so this whole thing is u, so it's u squared. So when I take the derivative of u squared, it's 2u to the first times du dx, like that. Okay, so I go back in and I'm gonna clean things up as well as substitute in my u's. Okay, so I have this cosine squared of 2x squared right there times, well, this would be negative 2 over u cubed. So it'd be negative 2 over u to the third power. Okay, so that'd be the sine cubed of 3x minus 5. Okay, times the derivative of this guy. So this is going to be times d dx of this guy. Sine of, sorry about that, guys. Sine of 3x minus 5. Like that. Okay, so plus. Okay, I've got this 1 over sine squared of 3x minus 5, okay, times 2u, and there's my u right here, okay, right there. So it'd be times 2 times the cosine of 2x squared, okay, times the derivative of u. Okay, so it'd be times, okay, and I have to come down here, I'm running out of room, d dx of my u, cosine of 2x squared, like that. Okay. So I can start sort of condensing things a little bit, okay, because obviously I'm running out of room here. Okay, so I could multiply these two guys together and make it into one big fraction, and obviously I'm going to have to take the derivative of this guy using the chain rule. Okay, so let's see, right here, I would get negative 2 cosine squared of 2x squared, right there, all over sine cubed of 3x minus 5. Okay, times. Well, right here I've got to take the derivative of this guy, so I let u equal 3x minus 5. Okay, so when I take the derivative, okay, the derivative of the sine is cosine, so I'm going to get cosine of u times du dx. Okay, and obviously we got to keep going there. I'm going to start cleaning this guy up here. Okay, so I've got a 2 up above, and I've got this cosine of 2x squared up above, and then down below I've got this sine squared of 3x minus 5. Okay, so right here, when I do the derivative, I gotta let u be 2x squared. Okay, so I take the derivative of cosine of u, so I get the opposite of the sine of u times du dx. Okay, all right, so let's see. Negative 2 cosine squared of 2x squared over sine cubed of 3x minus 5. Okay, times, well, let's see, cosine of u, and my u is 3x minus 5. So we'd have cosine of 3x minus 5 times the derivative of u, and the derivative of 3x minus 5 is just 3. Okay. All right, so again, I'm all done taking a derivative. I just got to clean things up there. Okay, so over here we have 2 cosine of 2x squared over sine squared of 3x minus 5 times, okay, sine of u, or I'm sorry, the opposite of the sine of u. So I get the opposite of the sine of u is 2x squared times the derivative of u. Well, the derivative of 2x squared is 4x. Okay, so I'm completely done doing derivatives. Now it's just how much can I clean this guy up? We don't know yet. Okay, so let's see. Okay, so I've got this 3, which I would multiply by the negative 2, so I get a negative 6. I've got this cosine of 3x minus 5, and I've got this cosine squared of 2x squared. Okay, and that's all over sine to the 3rd power, or sine cubed of 3x minus 5. Okay, and we come over here, and notice I have a negative here, so that's going to be minus, and then I have this 4x times 2, so I get minus 8x up above, okay, and then I'd have a cosine of 2x squared and a sine of 2x squared. Doesn't matter which order you put them in. Cosine of 2x squared, sine of 2x squared, and that's all over sine squared of 3x minus 5. Okay. You take a look and you ask yourself, is there anything I can do as far as cleaning things up, well, notice cosine and cosine squared, but they're two different things, so I can't do anything here. Obviously, they're two different trig functions. I can't do anything here. Okay, so I am looking at, this is one possible answer right here. Okay, I mean, if you wanted to factor out a -2, put it on the outside, you could do that because you have a GCF with the -6 and -8. You got a GCF of -2, but I don't see any reason to do that. So the only other thing we could possibly do is find a common denominator, okay, and combine them just like we did in the last one. So this is sine cubed of 3x minus 5, and this is sine squared of 3x minus 5. So if I multiply above and below over here by sine of 3x minus 5, like that, sine of 3x minus 5, okay, I could do that. Okay, so let's see if it cleans it up at all. Probably not. Okay, so when I do that, my denominator would be sine cubed of 3x minus 5. So I bring this numerator down, -6 cosine of 3x minus 5, cosine squared of 2x squared. And then obviously I got to take this numerator and multiply it here. Okay, so I'd get -8 cosine of 2x squared sine of 2x squared times the sine of 3x minus 5. And I don't see anything I can do there. Okay, so this guy is just like the last one where, your two possible answers are kind of ugly to look at no matter which one you choose. So whether it's this guy or this guy, okay, yeah, they get real busy, okay? And again, you're going to come up with these same answers if you go back to the original problem and you just say, let me just, use the chain rule on this guy with this whole thing being u, okay? And then when you take the derivative of u here, you'd have to use the quotient rule. So you're going to get these answers, or you're going to get something very equivalent to them, okay? Ugly as well. Okay, so that'll wrap it up for today.